Okay guys, a recap on example 3. First, we're just going to start with A on this video. So we're looking at unusual solution sets. So remember, we're solving nonlinear inequalities, so we need to first, well, we're going to find our x-intercepts and we're going to find our vertical asymptotes because those are the intervals that we create in our table that helps us find our solution. And so first thing is to find those x-intercepts. We know that the function has to have 0 on one side of the inequality, and it does. So we're going to set our function equal to 0 and solve. So this one can be done by factoring. So we get x plus 3 and x plus 3. And then remember, to find those x-intercepts, we want to set it equal to 0. So since they're the same, we say we get x equals negative 3. And then remember, that means it has a multiplicity of 2, just to cover that again. We didn't mention it in class, but just so we can remember, because the x plus 3 is there twice, that means that x-intercept, the negative 3, has multiplicity of 2, which if I was going to graph it, means it would touch it and then turn around. It would not actually cross through the x-intercept at that point. All right, and then vertical asymptotes. Remember, vertical asymptotes again are the uncanceled factors of the denominator, and I don't have a denominator, so that means I don't have any vertical asymptotes. Yay! All right, so once you got that, we're ready to set up our interval table. So let's do that. Okay, so we got the setup for our interval table here, and so we just need to create those intervals. Remember, again, they always start at negative infinity, and the last one will always end at positive infinity. And so we look at this problem, and the only number I have to split up that interval is going to be at negative 3. So our interval is going to go from negative infinity to negative 3, and then negative 3 to positive infinity. Remember, infinities always have parentheses, and the x-intercepts will have parentheses if there is no equal sign in the inequality, or it'll have brackets if it has an equal sign in it as well. We're looking at our inequality there. It's just greater than, so that means the x-intercepts also have parentheses. So we're going to pick an x value that's in between them. So we're going to choose negative 4 and 0. Plug that into our f of x, and we get 1 for the negative 4. And when we plug in 0, we get 9. Now both of those numbers are positive. So remember, to find your solution, you look back at the inequality in the problem here, so where we have the 0 at. So I see it's greater than 0, and what kind of numbers are greater than 0? Well, positive numbers are greater than 0. So both of these are going to be my solution. But the question here is it all real numbers, or is it just those two? What is the difference? That negative 3. Is it included or is it not included? Well, it's not going to be equal to 0, which at negative 3 we saw when we found that x-intercept. That is where it's equal to 0. So we can't say it's all real numbers here. So it's only going to be that negative infinity to negative 3 and from negative 3 to infinity. Now, if my negative 3's had brackets, which meant it had the equal to in the inequality at the beginning there, then negative 3 would be included, and we could get by with saying all real numbers are from negative infinity to positive infinity. But because this one, the negative 3 is not included, you have to write it as two separate intervals. Good job, guys.